Hello and welcome to Ashford.com. You are watching an interesting video on stress effects, a molecular mechanism behind this difference, potentially leading to better understanding of psychiatric disorders. Please read this disclaimer carefully. According to a new study conducted by health economists at the University of East Anglia and the Centre for Diet and Activity Research in the UK, walking or cycling to work is better for people's mental health than driving. The new study, conducted in mice, addresses why stress affects each of us in different ways. The study, conducted in mice with very similar genetic backgrounds, was conducted by researchers at Rockefeller University in New York, NY, and is published in the journal Molecular Psychiatry. According to the Centers for Disease Control and Prevention, CDC, depression is a substantial individual and global burden. If not treated effectively, depression can develop into a chronic disease. For example, just one episode of depression places an individual at a 50% risk for experiencing a subsequent episode, and further episodes increase the likelihood of experiencing more in the future. Though medications or psychotherapeutic techniques can be effective in treating major depression, the CDC say this disorder is still largely seen as a sign of weakness rather than as an illness. As such, senior author Bruce McEwen, of Rockefeller University, and colleagues decided to investigate how stress affects mice at a genetic level. Like people, each animal has unique experiences as it goes through its life. And we suspect that these life experiences can alter the expression of genes, and as a result, affect an animal's susceptibility to stress, he says, adding, "We have taken an important step toward explaining the molecular origins of this stress gap by showing that inbred mice react differently to stress, with some developing behaviors that resemble anxiety and depression, and others remaining resilient." To conduct their study, the researchers exposed the mice to unpredictable instances of cage tilting, altered dark light cycles, confinement in tight spaces and other unpleasant situations, with the aim of creating the stressful encounters believed to be a major cause of depression in humans. In subsequent tests, the team found that about 40% of the mice showed high levels of behaviors indicating the rodent equivalent of anxiety and depression symptoms, which included a preference for a dark compartment over a brightly lit one and lack of interest in sugar water. However, the other 60% of the mice handled the stress well. The researchers note that this distinction was evident before the mice were even subjected to stress. Some of the susceptible mice showed a preference for a dark compartment before they were stressed. Upon further examination, the researchers found that the susceptible mice had less of a molecule, called mGlu2, in the hippocampus, a region of the brain involved in stress. This decrease, the team says, arose from an epigenetic change, which affects how genes are expressed. If you think of the genetic code as words in a book, the book must be opened in order for you to read it, explains first author Carlin Uska, postdoc at Rockefeller and a fellow of the American Foundation for Suicide Prevention. These epigenetic changes, which affect histone proteins associated with DNA, effectively close the book, she adds, so the code for mGlu2 cannot be read. These epigenetic changes, which affect histone proteins associated with DNA, effectively close the book, she adds, so the code for mGlu2 cannot be read. Noska and her colleagues previously shows that a new potential treatment, known as acetylcarnitine, lessens symptoms of depression in rats and mice by reversing the epigenetic changes to mGlu2, resulting in increased levels. Commenting on their recent work, Noska says currently, depression is diagnosed only by its symptoms. But these results put us on track to discover molecular signatures in humans that may have the potential to serve as markers for certain types of depression. Our work could also lead to a new generation of rapidly acting antidepressants, such as acetylcarnitine, which would be particularly important to reduce the risk of suicide. According to the CDC, in any 2-week period in the U.S., 8% of non-institutionalized Americans aged 12 or older have depression. Furthermore, in 2011, there were 39,518 suicide deaths in the U.S., highlighting the need for further research into this disorder. References